On September 1, 1859, British astronomer Richard Carrington witnessed an extraordinary event, a massive solar flare that would alter Earth's technological future. This solar storm, known as the Carrington Event, sent electromagnetic waves crashing into Earth's magnetic field, causing widespread disruptions. Telegraph systems worldwide malfunctioned, fires broke out, and auroras were seen as far south as the Caribbean. Today, our world is far more reliant on technology, making us even more vulnerable to such a solar event. Imagine a scenario where a similar solar storm hits modern society, potentially wiping out communication networks and power grids. Understanding the Carrington Event is crucial for preparing against its potential recurrence and safeguarding our technological infrastructure. Scientists study historical records and solar activity patterns to predict and mitigate the impact of future solar storms. From early observations by Carrington to current research, humanity has learned much, but remains vigilant against the sun's unpredictable nature. Join us as we explore the Carrington Event and its implications for our increasingly connected and technologically dependent world. In September 1859, British astronomer Richard Carrington observed an intense solar flare, marking the beginning of the Carrington Event. This solar storm produced auroras visible across much of the Earth, disrupting telegraph communications. Telegraph operators reported sparks from their equipment during the Carrington Event. Some were injured when their stations caught fire due to the intense electrical currents generated by the solar storm. Modern technology is far more vulnerable to solar storms than 19th-century telegraphs. Today, such an event could disrupt global communication networks, GPS systems, and even power grids. The Carrington Event was one of the largest geomagnetic storms on record. Scientists estimate that a similar event today would cause trillions of dollars in damage worldwide. Solar storms occur when the sun releases bursts of magnetic energy, called coronal mass ejections, CMEs. These CMEs can hurl billions of tons of solar material into space. When a CME reaches Earth, it interacts with our planet's magnetic field, creating powerful geomagnetic storms that can affect satellites, radio communications, and power lines. Auroras, known as the northern and southern lights, are a spectacular display of the Earth's atmosphere interacting with solar particles during geomagnetic storms. Scientists monitor solar activity using satellites like the Solar Dynamics Observatory, which provides real-time data crucial for predicting and mitigating the impacts of solar storms. Understanding solar storms is critical for protecting our technological infrastructure. By studying past events like the Carrington Event, researchers can better prepare for future solar storms. The Carrington Event demonstrated the sun's immense power and the potential risks it poses to modern society. With advanced warning systems, we aim to minimize the impact of future solar storms. While solar storms are rare, their potential to disrupt global communications and power systems makes them a significant concern for scientists and policymakers alike. The Carrington Event remains a pivotal moment in the history of solar science. It serves as a reminder of the sun's unpredictable nature and the importance of continued research. Today, scientists use sophisticated models and simulations to predict the trajectory and intensity of solar storms, aiming to provide timely warnings to affected regions. Preparedness measures include strengthening power grid infrastructure and developing contingency plans for critical services, ensuring resilience against the next major solar storm. Despite advancements in technology, the Carrington Event highlights the enduring vulnerability of our interconnected world to natural phenomena beyond our control. The Carrington Event underscores the need for international cooperation in monitoring solar activity and coordinating responses to mitigate the impacts of future solar storms. By learning from historical events like the Carrington Event, we can enhance our preparedness and safeguard our technological infrastructure against the unpredictable forces of the sun. Continued research and collaboration are essential to understanding and predicting solar storms, ensuring the safety and stability of our increasingly interconnected world. As we continue to advance technologically, the lessons from the Carrington Event remind us of the ongoing challenge to balance innovation with resilience against natural threats. The Carrington Event teaches us that despite our technological progress, the sun still holds the power to disrupt our daily lives and infrastructure, emphasizing the importance of ongoing solar research. Through improved monitoring and response strategies, we can better protect ourselves from the next major solar storm, ensuring the continuity of our technological society. The Carrington Event serves as a cautionary tale, highlighting the need for constant vigilance and preparation against the unpredictable forces of nature, particularly those emanating from our closest star. By studying past events like the Carrington Event, scientists hope to unravel the mysteries of solar storms, improving our ability to forecast and prepare for future solar activity. The Carrington Event continues to inspire research and innovation, driving efforts to understand and mitigate the risks posed by solar storms, ensuring a safer and more resilient future for all. In 1859, telegraph operators worldwide experienced disruptions and damage to their equipment due to the Carrington Event's intense geomagnetic storms, highlighting the vulnerability of early electrical systems to solar activity. Modern power grids are susceptible to similar disturbances. A Carrington-level event could cause widespread blackouts, affecting millions and disrupting essential services for days or weeks without proper preparation. To mitigate risks, researchers monitor solar activity using advanced telescopes and satellites, aiming to predict and prepare for potential solar storms, ensuring critical infrastructure remains resilient. Understanding the Carrington Event's impact on Earth has spurred international collaboration among scientists and governments to develop strategies and technologies to safeguard against future solar storms. The Carrington Event serves as a stark reminder of our planet's vulnerability to space weather. As technology advances, so does our risk. Understanding past events is crucial for preparing future defenses. By studying historical solar storms, scientists can better predict and protect against potential disruptions. This knowledge helps safeguard our modern infrastructure from catastrophic failures. Imagine a world without electricity for weeks or months. The consequences would be severe. Investing in research and early warning systems is essential for preventing such a scenario. Governments and private industries must collaborate to develop resilient networks capable of withstanding extreme space weather events. This collective effort ensures global safety and stability. As we continue exploring space and advancing technology, it's vital to remember the lessons of the past. The Carrington Event teaches us to prepare and adapt for unforeseen cosmic challenges. Investing in solar monitoring technologies can provide critical early warnings, allowing us to take protective measures before a storm hits. These systems are essential for our technological society. Every day, solar observatories around the globe track sunspots and solar flares, alerting us to potential threats. This constant vigilance is necessary to protect our interconnected world. By learning from the Carrington Event, we can build a safer future. Understanding the risks and taking proactive steps are key to mitigating the impacts of future solar storms. In conclusion, the Carrington Event was a pivotal moment in history. It highlighted the potential dangers of space weather and sparked ongoing efforts to understand and prepare for similar events. We owe it to future generations to safeguard our technological advancements. By continuing to study and learn from past events like the Carrington Event, we ensure a resilient and secure future. Thank you for watching this journey into the past and future of space weather. Remember, the Carrington Event is a reminder that we must always be prepared for the unexpected cosmic phenomena that could affect our lives.